Hey, how's it going, everybody? In this video, I'm going to go through this Leetcode 347 top K frequent element. This is one of the most classic questions that you can come across on Leetcode. In the past 2 years, this question was asked by this many companies, so we can see that how popular this is. Given an array of nums and an integer of k, return the k most frequent elements. You may return the answer in any order. So for example, we have an array like this. The 1 appears 3 times, the 2 appear 2 times, and then the 3 appear 1 time. And then we need to find the top 2 most frequent elements. It's gonna be 1 and 2, right? Because the 1 appeared 3 times, and then the 2 appeared 2 times. So that's why this is the top 2 most frequent element. And because the 3 only appear once, that's why it's not the top 2. And here, this is a trivial case where we have only one element, and we are looking at the top 1 element, which is only itself. As well, there are some constraints over here, and also we have some complexity requirement that we need to satisfy. It's gonna be O n log n. I have 3 solutions over here. They have different time complexity. I'm gonna go through it with you all of them, and then you can pick the one that I think makes most sense to you, or you think the one that is most optimized one. So the first solution, it takes big O n times log k for time complexity. Let's look at it together. So if the length of the nums exactly equal to k, right, that means all the elements in the nums array, they are unique. This is a trivial case where you just return the numbers array itself. And then otherwise, if it does not return, and then we have a counter that counts all the frequency. When we call the collection stock counter, and then we will return a dictionary, the key being the value itself, and then the value is the frequency. So for example, if we put in this array, and then what comes back to this dictionary gonna be 1, and then appear 3 times, so 1 column 3, and then 2 column 2, and then 3 column 1, because the 3 only appear 1 time. So that's why I call it value to its frequency. And then we have a heap over here. Heap is one of the most popular data structure to handle the top K problems, usually. So for all the value and frequency in the value to frequency dictionary.items, and we push all the frequency and value pairs to the heap that we defined earlier. If the length of the heap is greater than k, and then we pop off. So essentially, this line over here makes sure that the length of the array, the length of the heap is always won't be greater than k, right? And at the end, we just return the value in the heap. One thing to notice is that in Python, the heap is always a min heap. So whenever we have the heap pop operation, we always pop the least frequent element. That's why whatever is left over here with a length of k, that is the top k most frequent element. So let's run that to prove that this actually works. And it does. Let's comment this out. And let's look at the second solution. Oh, before I jump to the second solution, maybe I can take one step back to look at the time complexity for the first solution. for this for loop over here, it takes big O n. Essentially, we are looping through all the items in the value to frequency dictionary. So potentially it can take up to big O n. And then when we have the heap push operation, so it's gonna be big O log k, because this is gonna be a heap. So the overall time complexity, as I mentioned earlier, so it's gonna be big O n times log k. And in general, this is gonna be better than big O n log n, because the k usually is gonna be smaller than n, right? So that was the time complexity for the first solution. Let's look at the second one. This one, it takes big O k times log n. In general, the time complexity in the second solution is going to be better than the first one, because the n typically is greater than k. That's why k times log n is going to be smaller than n times log k. If you do a simple example, and then you will figure out why. In here, what we do is same. First step is going to be the same, right? So basically, we are calling the collections library dot counter, and then time again the frequency of all the elements. I call it val to freq, and then I want to swap, because in here the key being the value being the frequency, and I want to swap so that the key gonna be the frequency, the value gonna be the vals, right? And I have a default dictionary, and the default element is gonna be a list for all the value and frequency pair in this counter dictionary. And then I have the freq to vals, and then with the key being the frequency, and then I append the value of the current element. Remember, everything in here is actually a list. That's why I can keep appending the value to that list. So after we come out from this for loop, we will have a dictionary where the key is a frequency, let's say a key of 3, and then the value could be any element of that frequency. Let's say if we have a key of 3 being the frequency, in here the value gonna be a 1 in that dictionary, in that list, because this is default on the list. And then we have to look at the negative frequency. The reason being, in Python, as I said before, a heap is always a mean heap, but we want to look at the top k most frequent, which could be the max. Well, by max I mean the highest k frequency, right? So to make that conversion, we have to convert the positive to negative to overcome the fact that we are using a mean heap. So to do that, we have a Python list for all the keys in the freq2 values. So all the keys in here actually just a frequency, right? And then we put a negative sign in front of it, and then have a new list for that. And then we call a heapify so that it will become a heap. And then we have a result list, and while k is greater than 0, and then we will keep popping off all the frequencies in here. Remember, in here we put the negative frequency, and then when we pop it off, we want to negate that so that it becomes a positive value. And then this one is being the key in the freq2 values dictionary, and then after that we have an array of values that correspond to that particular frequency, and then we just append that to the result. And then whenever we do that, we just minus whatever the length of the array is, so just so account for the top k. After this while loop is done, and then we just return the result. So let's look at the time complexity. In here, when we do the heapify operation, it takes big O over n. Oh, let me take one step back. When we keep the collection.counter, it takes big O over n as well. And here is another big O over n. So in total, it's big O 3n, actually it's still big O over n. In here, while k is greater than 0, and then actually this one takes big O k. For the heap pop operation, it takes a big over log n, because potentially we have n elements inside this heap or array. So in total, the time complexity is gonna be big O n plus k times log n over here. Actually, I forgot to put, could be, you need to plus the big O n as well, right here. For the same logic, we need to plus n here as well, but still here is still better than big O n log n. So this is the second solution. Let me comment this out. Let's look at the last one. It takes big O n, this solution. And the first step is the same as earlier. We are calling the counter to count the frequency of each element. The second step is also the same. We are basically swapping the key and value. And while we have the number of results, we started as 0, and then we have a result as an array. And for all the frequency, and then we go from the highest possible frequency and then -1. So we essentially go from the highest frequency and then go all the way to 0, and then each step is -1. So let's say in here the highest frequency is gonna be 6, because we have a 6th element over here, but none of these elements appear 6 times. That's why we are not going to be able to find any values for that particular highest possible frequency. And then we take the next possible highest, which is 5, and again there's none of the elements with frequency of 5, and then we take the next one, it's going to be 4, and same idea, none of the elements appear 4 times. And the next one is going to be 3. In here the 1 appears 3 times, so that will be one of the answer. And then we will take another step, gonna be a frequency of 2, which is the 2 over here. So to do that, we have a freq to values dictionary over here, and then we get the current frequency that we're looking at. If there's any element, we just take that, otherwise just have an empty list. And if the list is not empty, we will concatenate to the answer, right? Also, we will increase the number of results that we collected so far. If the number of results that we collected so far is exactly equal to k, we just exit from this for loop, and there will always be a solution. That's why we don't have to after this main for loop, we don't have to return anything, because this one will always be caught. And this solution overall takes big O n, because this operation takes big O n, and this is another big O n, and here is also big O n as well. So that is the 3 solutions to this problem. I hope you find this video informative. Thanks for watching. See you next time.